So let's take a look at a contextual problem, and I'm going to look at a few contextual problems as we go through here, and it's going to kind of be something that we're going to work on and we're going to work through a little bit. So this first contextual problem that we're going to look at gives us an example of the number of hours worked to the gross pay, or how much you would get paid based on how many hours that you would work. Okay? The number of hours worked is our time, so this is going to be our X value, or our horizontal or our independent variable, and the amount you're paid is based on how many hours you work. Okay, so this is going to be our pay, or this is going to be our vertical axis there. So when we have a coordinate point, we always do our horizontal value and then our vertical value. So this would be the coordinate point 112. This would be the coordinate point 224. This would be 336. This would be 448, and this one would be 560. Now, is there a direct relationship between the number of hours worked and your gross pay? Well, if it's all just regular time pay, yes, there is. And based on the chart that we've seen, we're going to look and see, is there a linear or straight line comparison between the two? So we're going to look at time versus pay is going to be our graph right here. And so our horizontal axis right here is going to be time worked, and this is in hours. And I'm just going to flip the page around right here, and this is going to be our gross pay, and that is in dollars. Okay, so we have our gross pay versus our time. Now when graphing it out, what I'm going to do is I got to get up to 5. So I'm going to start with 0 here. 1, 2, 3, 4, 5, 6, 7. I always make sure to label all the way through. Gross pay, I got to get up to 60. I'm going to 10, 20, 30, 40, 50, 60, 70. All right, so there's my labeling. Now, when we label a graph, we should always have some sort of title, unless it's just a generic. So any context, make sure we have a title. We have a label on the vertical axis as to what it represents, and we have a label on the horizontal axis as to what it represents. Okay? We don't just want to label it as X and Y. We want to label it as what are the two values actually are, unless there's no context, and then we can just put whatever we'd like into there. Now let's plot our points. When we plot our point, it's going to be where the 1 of X and the 12 of Y meet up. So along our X value, there's the 1, and along our Y, 12 is just above 10 here. So where they meet up is going to be this point right here. 112 is going to be that point right there. And we keep on going. 224 is going to be right about there. 224, and I'm going to try to label each of these points here. 336, again, labeling these points is very good practice. 36 is right there, so that's 336. 24 should be a bit up. Should actually be more like there. 4 is 48, so right there. 448. And 560 is a little bit easier because that one's right on there. So that's 560. All right, so there's my 5 points that I was given. Now what I can do is I can draw a line through those 5 points. And if I do that, it should be pretty close to a straight line. And I'm going to actually make sure that it's something like that. Now, with it being a linear function, okay, this could continue on. We could work 6, 7, 8, 9, 10 hours, whatever the case may be, and this line would be able to continue on forever. Now, we can't work negative, so it's going to stop right here. It's one of the restrictions we're going to put in place. We won't worry too much about restrictions right now, but we'll take a look at that next year when we get into graphing as well. Here is our linear function. Okay, it goes in a nice straight line. You notice that each of the points roughly goes through there. Now my graphing is not 100% accurate, but if we had a really nice graphing software, we would be able to get a much better line. Okay, so that would be our linear function. We have our points, they are labeled, we have a line that goes through there, And if we had an equation, we would want to write that one down as well. But for this point, we don't have an equation. Now, a couple questions just based on that. Would this graph provide a straight line? Yes. The amount you are paid is directly proportional to how many hours worked. There we go. Okay, became a little bigger than I thought I had there. So the amount that we're paid is directly proportional to how many hours are worked. It is a direct relationship. It is 1-to-1. So for every 1 hour you work, you get paid a certain amount of dollars, and so on and so forth, at least based on regular time hours. Now, we can use this graph as a representation of how much you will get paid based on certain number of hours. Okay, or we could use a function that is related to that as well, and we'll get into functions in a little bit and how they worked. So let's just predict the gross pay if 10 hours are worked. Well, we notice that we're going up by 12 every time. Okay, so that probably means we're getting paid $12 an hour. That's our rate of change. We'll deal with rate of change in a little bit as well. Okay, so we can take a look and we can extrapolate or go up above this graph to where hours is 10. And we want to guess how much it's going to be? Well, you probably guessed right. I'm hoping you guessed right. You will get paid $120 for 10 hours of work. Okay. Another way we can see that is we multiply 12 by 10. 12 is our rate of change. We multiply by the number of hours, which is our x, and that'll give us our y. So we can think of this as the y value is equal to 12 multiplied by the x value. Now this isn't a multiply sign, it's just 12 multiplied by x. Okay, again, it's variables, and so we can use this to represent our line. This would be what we would call a function. Now if we worked 40 hours, this would be $480 for 40 hours of work. Again, that's using this function to represent how much we're getting paid based on how many hours of work. Okay, this is a direct proportional equation here. Okay, and it gives us a representation of the pattern that is being formed.